So today we will be looking into the May OMB solution. So to look into the question says the function f defined by f of x given here, where a, b, c, d are non-real zero numbers, has the properties. The two properties are given over here. And then the last property, f of x is equals to x for all values except negative d by c, and we are asked to find the unique number that is not in the range of the function given here. So to first solve this question, we can take hint from this equation given here. So using this, we can say f of x is equal to, so f of x here is the value of x, so we can substitute it here. So instead of x, we can write this value given here, p of x plus b divided by c of x plus d, and then we can say plus b whole divided by c, p of x plus b divided by c of x plus d plus d. And we can see that both the whole numerator and the denominator has the same denominator here, so we can cancel it, and upon multiplying we will get x plus b times cx plus d. And since the denominator for the whole numerator and the whole denominator is same, we can just cancel it. Plus b plus d times c of x plus d, and on further multiplying we get a square x plus ab plus bcx plus bd whole divided by cax plus cb plus dcx plus d square. So as we can see, we have x squared and we have x in both the numerator as well as the denominator. So what we can do is we can make x the common here, so we get ax squared plus bc plus, and in this case we can see that b is common, so we can write it as a plus d. And in case of the denominator, we have x ca plus, and in this case we have cd, and we have taken the x as the common here, and then we have cb plus d squared. So we know that f of x is equals to x, so we can just write it as x in this case. Now to simplify this equation, we can say let a squared plus bc be equal to k, kl be equal to b a plus d, m be equal to ca plus cd, and then n be equal to cb plus d squared. So we can rewrite this equation as x is equal to kx plus L whole divided by mx plus n. So this is the simplified equation that we get by using this condition given here. Now what we can do is, if we cross multiply, you can see that mx whole squared plus x times n, which is equal to kx plus L. Now what we can do is we can take everything to the left hand side, so that on the right hand we have 0 minus kx minus L is equals to 0. So what we can do here is, so we will take this equation up here, mx squared plus we can take x as the common here, which is equals to n minus k minus L is equals to 0. So we get this quadratic equation. So from here we can say that if this left hand side is to equal 0, m has to be equal to 0, n minus k has to be equal to 0, which means n is equals to k, and negative L is equals to 0, so L is equals to 0 as well. Now in this case, let's focus on this equation over here. We can see that m and L, they are equal to 0. But what about k and n? If k and n are also equal to 0, then we can see that it will make the function undefined. So therefore we can say that n is equals to k is not equal to 0 in this case. So with this condition in mind, what we can do is we can say that m is equals to L, which is equals to 0. So we can say m, which is equals to CA plus CD, is equal to L, which is given here as B A plus D in this case. So we can either take this as 0 or the right part as 0. So if we take this as 0, then we get B A plus D. So we get B is equals to 0 in this case. Plus D is equals to 0. So B is equals to 0. We get this. But according to the condition we have, B is a non-zero real number. So this condition is false. Now, if we consider the right part to be equal to 0, then we get CA plus CD is equals to 0. And we can take C common out, divide it here, and then we'll still get 0. And we have A plus D in this case. So A will be equal to negative D. So we have A is equals to negative D here, which we can use to redefine this function given here. So we can say f of x is equals to ax plus b whole divided by cx. So we can say d is equals to negative a as well. So we can write d instead as negative a. Now we can use the help of these two functions given here. So we can write f of 19 is equals to 19 only. So we can write 19 is equals to a times 19 plus b whole divided by c times 19 minus a in this case. So we'll get 19 square c minus 19a, which is equals to 19a plus b. And we can consider this equation 1. And as for equation 2, we can take f of 97 is equals to 97. So 97 is equals to a, 97 plus b, c 97 minus a. So if you just substitute, we'll get 97 square c minus 97a is equals to 97a plus b. So we can consider this as our equation 2. So we can take equation 1 here, 19 squared c actually, which is equals to, so we can take 19a to the other side, which becomes 38a plus b. And we can also do the same here, 19 squared c, so 97 squared c, which is equals to 194a, 194a plus b, upon taking the negative 97a to the other side. So what we can do is we can subtract equation 2 by equation 1. So upon subtracting, we will get 9048c, which is equals to, so b and b will cancel. So the value of a we will get is 156a. So we will get the value a by c as 58. So this is the unique number that is not in the range of the function given here. So we have used the help of these equations given in the question to help us find our final answer. Thank you.